So, welcome to this lovely session of building building web apps on AWS with AWS CodeStar and Elastic Beanstalk. Yes, that is the name of the session. Before I start, just a show of hands, who has never used AWS before? Okay. You might learn something today. So, first of all, who am I? Why should you listen to me, or should you listen to me? My name is Darko Mesaros. I originally come from Subotica, Serbia. Currently, I live in Berlin, Germany, and I'm a specialist solutions architect. What is a specialist solution architect? So, my job is to help customers such as yourself with some specific topics. So, my specialization is AWS Marketplace and the management tools. So, for all the CloudFormation junkies, all the CloudWatch junkies, CloudTrail, all those sexy governance tools, I'm the person to ask those things. Also, besides that, I kinda also specialize in DevOps, so hopefully I can translate some of that knowledge to you today. So, before we start, this is kind of something I would like to cover today with you. So, if my clicker would work in a due time, yes. I would like to talk about a modern application. Why, what, and how. I would like to help you focus on your code. And finally, for a bit more traditional audience, my presentation sucks. I would like to have Elastic Beanstalk do the work for you. So, let's start. See? I'm pressing it. Wait. There's always the old way. It's fine. I think I can manage. So, modern application. Why, what, and how? Who knows what a modern application is? Can somebody define a modern application? I'll give you a sticker. Nobody? Really? Wow, okay. Wow, that's... Does anybody here deploy a modern application? No. Wow, okay. That's interesting. So, well, a couple of things that we at AWS think are the tenets of a modern application. It's 2019, so you should go serverless, right? Focus on microservices. Make sure you do everything as code, which includes the infrastructure. Push all of that through a pipeline. Understand how is what doing. Be aware of how your environment looks. What is the current state of your application? Is it healthy? Does it deliver business value? And at the end of the day, you have to build in security to it. Since we have 2 hours for this presentation, I'll go through all of these. I'm just kidding. I'm just going to talk about CI/CD. So, can anybody tell me what is CI/CD? Come on, don't be shy. We just had coffee. Please scream it out. Continuous integration and? Or deployment? Both? Maybe? But okay, you get a sticker. I have a SAM sticker, a DynamoDB sticker, a Cloud9 sticker, and an Amplify sticker. So please let me know afterwards. So what is CI/CD? Continuous integration, continuous deployment or delivery. So to show it a bit more graphically, these are the most common 4 steps of application development cycle, or application deployment cycle, how would you like to call it, right? So you have the source, the build, the test, and the actual production or deployment phase. In a CI setting, the CI part of CI/CD is just building it, sourcing it, committing a code to a Git repo, or SVN, or Mercurial if you're crazy, and having it built. At the end of the day, you get an artifact outside of that. Continuous delivery is the same thing as CI/CD. Just on top of that, you also have integration tests, and somebody has to manually say, yep, ship that to production. So it's not a fully automatic system. All of the elements here can be automatic. From the build to the test to even the deploy can be automatic, but somebody has to just say, ship it, and that should be good. And at the end of the day, the continuous deployment, the holy grail of it all, is you commit your code, it builds, it's tested, and at the end of the day, it goes to prod automatically. Luca mentioned yesterday that you should not push every commit to production. Absolutely. So this includes all the testing, development, and staging environments in between. So at Amazon, we do have, I would say, a continuous deployment setup. So you commit your code. It goes through all the different testing, all the integration and unit tests you want. It goes through canary deployments, and then at the end of the day, it's available in prod. So what did CI/CD do for us? According to a DORA State of DevOps report from last year, it has actually decreased or increased the deployment frequency. So I used to work for a company back in Serbia where we used to deploy software, internal software, every 4 months, right? So the process was like this. We had an application team. They would code their application in Java. When they think they were done, they would tell us, hey, here's a disk. Push this to production. Then we would manually copy it to a whole bunch of application servers, and hopefully it works. If it doesn't work, tough luck. Wait for months. So, and we have changed with the concept of CI/CD, right? To increase the frequency of deployment from weeks and months to basically days and hours, right? I don't have the exact numbers here on this presentation, but in 2011, Amazon did 156,000 deploys per day. So that's a lot, right? There's a massive change in lead time, from a couple of months to 1 to 7 days, right? So you don't need as much as time to perform a change. So I'm talking here about application changes, but I'm also talking about infrastructure changes. This is the cloud. We can templatize everything as code. So even infrastructure changes do not have to be massively planned up ahead. With the proper CI/CD controls in place or proper pipelines, you can just do that, well, relatively fast. And we hate to fail, right? So the failure rate with proper tests on a pipeline has actually massively dropped. But these are all fancy numbers, and that's all cool. Now, how can I explain to you developers, or sysadmins, or engineers, how can this apply to you? Well, at Amazon, AWS, we have a set of services that kind of cover all of these things together, right? So from AWS Code Commit, which is our Git solution, to Code Build, which just the builds and tests to an extent, to AWS Code Deploy, which as the name says, deploys your code, all connected through AWS Code Pipeline as it is a pipeline. And we don't have testing tools yet because there's much better third-party tools out there to do like integration testing, penetration testing, security testing, all the load testing you want. And all of this is available through AWS CodeStar. I'll explain in detail what each of these elements are. Maybe this has, oh, it started working. So, CI. As I mentioned before, it works when I do this. So, CI, it's just this part, right? So, instead of having these two things, it is just continuous integration. And what tools from AWS help you in this part? So, Code Commit. Code Commit, simply put, is our Git solution. Code Commit is just a standard run-of-the-mill Git solution that's based on AWS S3, DynamoDB, and AWS KMS for encryption. So it supports most Git features. It uses the standard Git tooling set. It's nothing proprietary. There's no repo size limit. That's very important. And it's relatively cheap. It's, for the first 5 users, it's free. And then as you go further, I think it's $1 per user per month. So compared to some other solutions out there, it's relatively cheap. And it's very robust. Now, the second part is Code Deploy. What is Code Deploy? Well, it deploys code. So it's a service that helps you take an artifact from any location. It can be GitHub. It can be Bitbucket. It can be an S3 bucket. It can be Jenkins. You take an artifact, and you automatically can deploy it to any resource. It can be an EC2 instance, a virtual machine in the cloud. It can be a container registry. It can be a Lambda function. You can even deploy this to virtual machines outside of AWS. So now, that's all good. A lot of tools do that. One of the really important aspects of code deploy is this ability to roll back changes. Has anybody had a problem? Well, has anybody ever deployed code and then it broke and then it took a while to roll back? Right, everybody, yeah, of course. So the problem when you deploy code, I did it myself a few times. You know, we used to do it manually. You open up WinSCP, just take a directory and copy it and just, you know, hope it works. So, and it doesn't. A lot of times it doesn't work. So what do? Oh, okay, let me find the old version and copy it back. Oh no, this file wasn't present there. Where's the other file? Oh, okay, this file was changed and this wasn't. Let me try to see what has actually changed. It takes a while. And in this modern high-velocity world, you know, we talked yesterday and today about how you have to move fast. Manual rollbacks don't cut it anymore. So code deploy actually does this for you. So what code deploy does is that it's aware of the previous states of files. So if it deploys your application code, and then all of a sudden it doesn't work, it can automatically detect if your application is healthy or not, based on how you configure it. It actually rolls back. So it says, okay, well, this deployment sucks. Roll back to the previous version, canceled. So you don't have to do a thing, right? So it's all automatic for you. So that is quite important. I'll not be showing code deploy today, but I'll be showing some other services as well. The thing that connects these services together is code pipeline. We have a fun way of naming things. I think the code services are very concrete in naming things so that you actually know what the service does, unlike some other services. It's a continuous delivery pipeline. Literally, it's just a pipeline. So it's a pipeline that moves your code from A to B, so with all the steps in between. It supports all the AWS code providers, but most importantly, it supports third-party providers. So you can use third-party test suites. You can use Jenkins. You can use GitHub. So it's all built into it, and it's very good because it reacts on any code change. So if you commit something to your code, it automatically picks it up, does the thing. It can deploy CloudFormation templates. It's not just a matter of like it builds your code. It takes your code. It can deploy a completely separate testing environment, deploy your code there. You can have manual approvals on it, so it has the entire tool chain you need for a proper CI/CD. Now, continuous deployment is... My slide decks are messed up. Okay. So, as I've talked about before, because I have repeating of the slides here for some reason. Okay, CD, again, I mentioned before, what is CD? Continuous deployment and continuous delivery. It's just a way of automating the rest of that part. And the same tools also apply there, code deploy, and, well, did I show code build? No? Ah, see? Okay, I've added code build where I should have added code deploy. Imagine this is code build. It's a similar icon. So code build, what is code build? Can anybody guess? It builds your code, yeah. Actually, it does build your code, absolutely. But code build is more of a tool that runs a set of commands against an artifact. So it takes an artifact, usually a commit from a Git repo, and you tell it, hey, with this artifact, just run Maven, or just run PyTest, or run npm install, and generate 7 gigabytes of data. So any of those things, you can literally arbitrarily run any piece of code. So it's used for, of course, building, but it's also used for testing. And it's also, a lot of people use it to run arbitrary commands on AWS, which is good and bad. So code build is this nifty little service that's charged by the minute. It basically runs a container in the backend that actually builds and or does something with your code. Now, the last aspect of our code services is AWS CodeStar. And what do I mean about focusing on your code with CodeStar? So long have been the times since you had a sysadmin who would manage your web server, and then somebody else gives him your code, that person deploys the code, and this entire process just has 2 people or 4 people, and you miss out on the opportunities to use these people's strengths for other things. So instead of having a person just focus on infrastructure or having a person focus on both, why not focus on your code? Because, let's be honest, the code is what brings your company value. It's usually not the infrastructure. So focus on the thing that actually brings your company value, that moves you forward, and let us do the undifferentiated heavy lifting for you. So when it comes to CodeStar, CodeStar is a service that integrates all the things I talked about before, plus more, to help you quickly deploy web applications, serverless application, Alexa skills, whatever you would like on AWS with all the best practices built in. All the CI/CD pipelines you need, all the whole lot of, you can get even an IDE on it. So you can get Jira integration, you get a wiki page, and it helps you collaborate because it has this multi-user setup that you can have more users working on the same project. So, so some notable features of CodeStar, right? First feature is free, right? A lot of services at AWS are free. You pay for the underlying infrastructure, but the CodeStar service in itself is absolutely free. It has an integration with Cloud9 IDE. Who knows what Cloud9 is? You? You get a Cloud9 sticker. There you go. So Cloud9, it is a browser-based IDE. It doesn't suck as much as it sounds, trust me. So it has Vim keys, you can use it at Vim, it's a terminal in the browser, it's good. I'll show it to you later. It works with all these services, right? So you're able, as I said, you can deploy software on EC2, you can do it on Lambdas, you can do it on Beanstalk, you can also do it on Alexa as well. And it has integration with GitHub, Atlassian, and Jira. So think of CodeStar as this push-button solution where you click something and it deploys all of these things and helps you get started really fast in working with your code. So actually, let me actually do this demo. I have some time left. My mic. Turn this on. Turn this on. I guess you can hear me now, yeah? Awesome. Cool. Yes. So what is CodeStar? This is how CodeStar looks. I hope this is big enough. Let me create a new project here. So I will select running Python and serverless, right? I will name it OPythia. Right? It's a horrible pun, I know. So I will create a project called Opythia, and I will store my code in code commit. I can also choose GitHub here, but yeah, I work for AWS, so it will create a repository for me, and it will also create all of these things for me. It will create a code pipeline. It will create code build for testing and building Python code. It will also use AWS CloudFormation to deploy this code to my Lambda function. And of course, at the end of the day, it will use Amazon AWS CloudWatch to monitor it because monitoring is an important aspect of it. Finally, in order for me to edit my code, I can also use my Vim. I can use Eclipse. I can use Visuals. I can use anything I want, but I'll opt in to use Cloud9 just to show you this online editor. So simply Cloud9 is an EC2, a virtual machine running in your environment that has this IDE software running on top of it. Click Next, and that's it. It's setting up my whole project, including everything I need to run a serverless application, a whole CI/CD pipeline. It should all be there. Now, as any good cook or a cooking show, I have it all pre-baked. So this is how it looks once it's done. You see, this is the dashboard where you have a wiki, because everybody needs a wiki. You can actually see your application if I click here, and because this is just a backend Python application, just spits out JSON. If you go here, you can see my commit history, or the blame game. And on the right-hand side, you have the pipeline, which is in this case a vertical shows from source to build to deploy, and you can see the monitoring aspect of it. And if we have a Jira set up, I can integrate my Jira here. So let's see how all of this works. So I've deployed my application that just outputs hello world. That's all fine and dandy. But this is Cloud9. So this is how a Cloud9 development environment looks. By default, it's white, but I've set it to black. It's just a simple browser-based IDE, which I can use as with anything else. So let me try to change something here. This is a Python application. So hello world, I'll change hello. What here? Good. I've changed my application. Now, any software developers here? Do you know what test-driven development is? Yeah? Did I make a mistake? Maybe. I wrote my code before writing a test. Test-driven development is you write your test, then you write your code. So luckily this sample application has a test built into it, but because I changed something, I need to change the test as well. If I look at the test, this test in itself expects hello world. So to change that, yeah, all right. And then as any standard Git tool, I can just do the Git. Oh. And now, I made a change to my code. I didn't have to call a guy. I didn't have to call a team to build it. I didn't have to call a team to test it. I didn't have to call somebody to say, hey, in a month, could you please deploy this to production? This is all going automatically or automagically through the pipeline. So in a few seconds, hopefully, on the left-hand or on the left-hand side, yeah, you should be able to see the source being picked up, and it should go through the entire build pipeline. Fingers crossed. Let's have a look. Refresh it for posterity. Okay, eventual consistency. So the source has already been completed. So the pipeline has detected a commit in my code commit repository. It has picked up said commit, pulled it out as an artifact to code build. In this case, code build, well, you don't build Python code. What it does here, it actually just tests Python code. And at the end of the day, it will deploy said Python code to my Lambda function, right? It takes a few minutes to deploy to a Lambda function due to the way API Gateway works with the different versions of a Lambda script. So we're just going to wait for it. Well, I'm going to talk about something else. But just to roll back on CodeStar, currently, there's only a limited set of templates you can use here, right? You know, from running C#, Go, HTML, Java, Python, and PHP, I guess, to running stuff on EC2, Lambda, or Elastic Beanstalk. And this is expected to grow. We should have more of these options available for you here. Okay. Has this thing changed? I don't think so, but it's still deploying. So let's continue talking about something else, because what is my time? Is my time up now? Oh no. Oh well. That's when you do a demo. So I'll just do a quick thing before I will not let them kick me off the stage. Just talk a bit about Elastic Beanstalk, because Elastic Beanstalk. Can I get just a? Thank you. Okay. So does this work? Yes, it does. Okay. So what is Elastic Beanstalk and why is it important? If you're starting up with AWS, you most likely have a very classic web application that runs on a server. It's a Java Spring Boot. It's a Ruby, whatever, some sort of a more traditional application. So what Elastic Beanstalk does is helps you to create this traditional environment, right? A set of servers behind a load balancer that run a specific application stack with ease. It's literally a push-button solution. It provisions all the required infrastructure, all the virtual machines. It provisions the load balancers in front. It configures the auto-scaling on it. So if your application load goes over X, it will automatically scale out. It also has has built-in deployment procedures with it, so it's easy to roll back on a piece of software if it broke. And it's a very hands-off approach. It's a very opinionated way to do it. We tell you how you should run your application, but you literally just pass it a zip file. Here's my application, run it. So I was hoping to also show this and demo it up, but I will not be able to do it in 30 seconds. So yeah, these are all marketing slides, etc., applications, but how to get started, you just go to the console. You can do it through the web console, you can do it even through IDEs, and you can do it through CLIs. So we like to give people the freedom to do it the way they want it. Before I go, I just want to give, I wish I could talk about best practices, but one of the best practices not regarding AWS, never do this. Please never, when you have dependencies, never use the latest tag, because that can bite you in the ass. Always version pin your stuff. So this is like a general good advice when you do. It's not AWS related, but it's just a general good advice. And finally, going back, forward. Yes. Summary. Automate everything. Don't trust yourselves. Do not trust yourselves to make good operational tasks. Automate everything. Everything moves fast now. You will not be able to do it yourself. Absolutely, move fast. Try new things, right? Try new services. Try serverless. Try containers if you haven't ever, and do it safely. Do it through infrastructure as code. Make sure if you do something and it breaks, it's easy to roll back. And let us, AWS, let the managed services, let the whole lot of things that you don't need to manage do the work for you and focus on your application code. Last but not least, our DevOps blog. I highly advise that you read there. A lot of smart people right there. And we have our 10-minute tutorials for like doing a web application development or all kinds of DevOps type of stuff on AWS. And before I say thank you, any questions? Yes?
So wait for Michael, can you repeat that?
We need to give, you need a talking stick.
So my question is, I've jumped into AWS ecosystem, set up a code deploy tool for my client, and it turned out that it has a memory leak, which was reported 4 years ago.
Okay.
How are we supposed to trust AWS with the dev tools if they're not able to fix a memory leak in one of the major tools for deployment for 4 years? I haven't wanted to go to use the other code tools, being bitten by this one.
Okay. Well, so I actually remember this issue. So there was this problem with an, It still is, okay. So the agent for a code deploy had a memory leak on it. Now, these things happen, right? I know. Do you know how many services we have? So yeah, absolutely. What can I say, right? So sometimes that can happen. Now, we have thousands of customers or tens of thousands of customers that use code deploy and use code services without a hitch, right? So now it can happen that you have a memory leak and that can cause a problem if you use small instances or if you exactly, yeah. So, you know, there's other ways to go around it. Like, I believe that the code deploy service team is aware of that problem, especially after 4 years. Now, why hasn't it been fixed? I really cannot say. But I can assure you that all our other code deploy services, and even code deploy itself, are quite extensively used and are very active in the developer tools community, for sure. So, but if you ever notice a problem, please do let us know. We are, and not let us know via somebody or telling me on stage. AWS support, they report those things directly to the service teams. I used to work in support.
I mean, it's open on GitHub.
Yeah, on GitHub.
So where we, the fact is that 4 years later, nothing happened.
Okay.
And it's a question of trust. How am I supposed to trust the other services if this one was giving me pain?
Okay. Fair point. All right. Well, I'll definitely look into that. Thank you very much, and I hope you enjoyed this session.